So in this video, we'll just be looking at some basic problems using Vieta's formulas. So I will just look at a few problems to, some basic ones, not too hard. Maybe I'll have another video which has some advanced techniques, but in this video, we'll just look at some common basic techniques using Vieta's formula. So first question is given, so let's look at x squared minus 4x plus 9. And let's say it has roots R1. Actually, I'll put this in another color so that I can distinguish it as a question. So question 1, x squared minus 4 x plus 9 has roots R1 and R2. Then find the value of R1 plus R2, R1 times R2, R1 squared plus R2 squared, and wait a second. Oh, this always happens. Okay. 1 over R1 plus 1 over R2. There we go. Okay, that looks a bit tilted, but it's fine. So, if you look at A and B, they're pretty straightforward using the Vieta's formula. So R1 plus R2, that's just the sum of the roots, which is negative B over A. So in this case, negative 4 over A. I'll just write it down. Negative of negative 4 over A, which is just 1. So that's just equal to 4. And R1 times R2 is just 9 over 1, in this case, C over A. And that is equal to 9. So yeah, A and B are pretty straightforward using Vieta's formulas. So yeah, if you're watching this video, I'm assuming you already watched the video for Vieta's formulas, the introduction video. And if you have not, I strongly recommend you to go to that video and then return to this video, or else you won't understand what I'm doing here. So these two are pretty straightforward. Like, they're really straightforward. But what about these? These are, So what we want to do is that since we know the values of R1 plus R2 and R1 times R2, we want to use these expressions to use these values to find the values of these. So we can put this in terms of these expressions to find its value. So R1 squared plus R2 squared, in fact, is equal to R1 plus R2 squared minus 2 times R1 times R2. And this is true because we know that R1 plus R2 squared is equal to R1 squared plus R2 squared plus 2 times R1 times R2. And so we just basically just minus this from both sides and we get this. So that's good because we can now substitute these values into here. We put this expression in terms of these expressions. So R1 plus R2 is just equal to, R1 plus R2 squared is equal to 16. And then this is equal to 2 times the product of R1 and R2, which is equal to 2 times 9, which is 18. So that is just equal to negative 2. So R1 squared plus R2 squared, wait a sec, R1 plus R2 and R1 times R2. Okay, yeah, it's equal to negative 2. And yes, it's equal to negative 2. And 1 over R1 plus 1 over R2 in this case. We'll do the same thing. We're going to put this in terms of R1 plus R2 and R1 times R2. So if we common denominator, that's not a word. If we try to do combine these fractions together, then we get R1 plus R2 over R1 times R2. And again, yeah, we put this in terms of this and this. So this just simplifies to r1 plus r2, which is equal to 4, and that's equal to 9. So we get that 1 over r1 plus 1 over r2 is equal to 4 over 9. So there we go. So these were just Vieta's formula, but then we use Vieta's formulas to find these values without even knowing what these roots are. And yeah, the reason I hesitated here was because the sum of the squares was equal to a negative number. I was like, what? But then, yeah, the roots are imaginary numbers, which is why this happens. But yeah, that will be discussed somewhere else, I guess. So yeah, this is how so basically we just put these expressions as in terms of these expressions to find the values of these complex expressions. So, okay, next problem. I'll just do it below here. So, next problem is, this time let's look at a cubic actually. So 5x cubed minus 10x squared plus 5x plus 3. Let's do that. Oh no. It's kind of tilted. I'll try to write it straight. Okay. Let's say it has roots, let's say it has roots r1, r2, and r3. Okay. And we want to find the value of, so we want to find the value of, let's say, okay, let's do this. r1 squared plus r2 squared plus r3 squared. There we go. Again, so let's try to put this expression in terms of r1 plus r2 plus r3. And actually, let's just write down what we know from Vieta's formulas. So what we know from Vieta's formulas is, so the sum of these roots is equal to negative b over a, which is negative of negative 10 over 5, which is equal to 2. And r1 times r2 plus r2 times r3 plus r1 times r3 is equal to, oh no, the 3 looks really bad. Oh my god. R3 is equal to 5, c over a, which is equal to 5 over 5, which is equal to 1. And r1 times r2 times r3 is equal to 3 over 5, which is equal to d over a, negative of d over a, so it will be equal to negative of 3 over 5. Yeah, I might be going a little fast because I'm not really reminding you of the Vieta's formulas, but yeah, it should be pretty straightforward, I guess, because there's a clear pattern going on. So yeah, we know these values, and we want to find r1 squared plus r2 squared plus r3 squared. And if we do that, and we notice that r1 squared plus r2 squared plus r3 squared is in fact equal to r1 plus r2 plus r3 squared minus 2 times r1 times r2 plus r2 times r3 plus r1 times r3. Oh my god, my 3's aren't working today. Okay, so it's equal to that because we know that r1 plus r2 plus r3 squared is equal to r1 squared plus r2 squared plus r3 squared plus 2 times the pairwise products of r1, r2, and r3. So yeah, again, we put this in terms of expressions that we know the values of, so we can just substitute them in. So that is equal to 2, so 2 squared is equal to 4, and that is equal to 1, so 2 times 1 is just equal to 2. So we get that the value of r1 squared plus r2 squared plus r3 squared is equal to 4 minus 2, which is equal to 2. So there we go. Well, that was fairly simple, I guess. Yeah, so if we look at these two problems, basically we're just, if we're given an expression with, an unusual expression with the roots, then we can just use these expressions. We can put this in terms of these expressions that we get from Vieta's formulas to get its value. So yeah, those two problems were pretty nice. And actually, let's look at another spicy problem. So I'll just erase all of this. I should have given you guys time to do the first two problems, but yeah. I hope you guys understood it. So the third problem, I'll put this in blue. The third problem is, let's see. Let's say we have the quadratic x squared plus 2x plus 3. And it has roots. These are all the same types of problems. Maybe I have another video on some more complex complex problems. R1 and R2. Then find the quadratic. Find the quadratic. Oh no. Whose roots are 1 over R1 and 1 over R2. The main purpose of this question is I guess to practice your Vieta, but also to try, show you something really cool. So firstly, this problem is I guess a bit different from the first two problems. So it's asking you to find the quadratic whose roots are these. So let's say this quadratic is, okay, that's red and black, is x squared plus bx plus c. Then by Vieta's formulas, we get that so negative b over a, but a is equal to 1 in this case, so negative b is equal to, so the roots of this quadratic is 1 over r1 and 1 over r2, so it's going to be equal to 1 over r1 plus 1 over r2, and and the product of the roots, c over a, but a is 1, so c is equal to 1 over r1 times 1 over r2. And so basically we just have to find the values of these things so that we can find the values of negative b and c so that we can get the quadratic that we're trying to find. So again, we already found a way to do this before in question 1. This is basically just r1 plus r2 over r1 times r2. And we know that r1 plus r2 is the roots of x squared plus 2x plus 3. Actually, let's write the formulas down here to remind ourselves. So r1 plus r2 is equal to negative b over a. So in this case, negative 2 over 1. So it's equal to negative 2. Oops. Negative 2. And r1 times r2 is equal to c over a. So 3 over 1 in this case. So 3. And yeah, so here, this will be equal to negative 2 over 3. And here, this is basically just 1 over r1 times r2, and r1 times r2 is just 3, so this is equal to 1 over 3. So from these two equations, we get that, I'll write this another color actually. We get that b is equal to 2 over 3, and c is equal to 1 over 3. There we go. So we get the quadratic x squared plus 2 over 3x plus 1 over 3 equals 0. And let's just multiply 3 on all of them to get rid of the fractions. And we get 3x squared plus 2x plus 1 equals 0. Yeah, so these will be the roots of this quadratic. And what do we notice here? We notice that this quadratic is basically just the coefficients reversed in reverse order here. So it's like 1, 2, 3. A equals 1, b equals 2, c equals 3 here. And here is a equals 3, b equals 2, and c equals 1 here. And the roots become reciprocals if we do that. So that's pretty interesting. And maybe I'll make a video on that, but we'll have to see. So, yeah. So this is how it works, I guess. So given expressions, we can use Vieta's formulas to simplify or find the values of those expressions. So yeah, that was a video on problems for Vieta's formulas. Maybe I'll have one for more advanced problems. But yeah, these are the basic techniques that are needed to use Vieta's formulas in math questions. And yeah, this is a really important theorem, so I hope you remember it and have a good idea of how to use them in math competition problems. So yeah, I hope you enjoyed this video and see you in other videos that I made.